In this lesson, we're going to learn about how light is produced, and our goal will be to understand various sources of light. Let's begin. Last lesson, we learned that light is a type of electromagnetic radiation, which consisted of a wide variety of types of light. For example, radio waves, microwaves, X-rays, gamma rays, etc. For the rest of the unit, we're going to focus on visible light. So, have you ever thought about where light comes from or how it's produced? A common misconception is for people to believe that light only comes into your eyes from a source. Probably the most important source of light, which is responsible for all life on the earth, would be the sun. In your house, a source of light would be a light bulb. If you've ever gone camping, a source of light would be a fire. Even your cell phone is a source of light, your computer monitor, all of these give off their own light. But that doesn't tell the whole story. Look, for example, at a pen or pencil in your hand. Clearly, that object doesn't give off its own source of light, but you're still able to see it. And that's because in reality, light is entering your eyes from all objects that you can see. Some objects produce and emit their own light. This would be like the sun, light bulbs, your laptop screen. But other objects can't produce light, but they can reflect light. And that's why you can see them when there's a light source in the room. But if you went into a pitch black room, you wouldn't be able to see your pen or pencil that you're holding in your hand because it's not a source of light. Next up, some definitions. An object is luminous if it's a source that can produce its own light. We've already talked about a few examples, but we'll reiterate them here for clarity. So of course, the sun, a light bulb, a lit match. You can imagine in the night sky looking at stars, for example. All of these objects produce their own light. An object is non-luminous if it cannot produce its own light. And once again, they can only be seen due to reflected light from a luminous source. Another big example that you see in the night sky would be the moon. Although the moon looks bright, the reason why you're able to see it is because it's reflecting light from the sun. I already mentioned the pen or pencil that you hold in your hand. When you're in school and we present off of the projector screen, that would be another example. The projector itself is a source of light because it has a light bulb, but the screen is not a source of light. Rather, it's reflecting the light from the projector. And what you'll discover is that most objects that we encounter in everyday life are actually non-luminous. If every object was luminous, you can imagine that the world would be a very bright place. So let's summarize by looking at this flowchart below. We'll start with light. Light can either come from a source, that would be a luminous object, or it can be reflected, that would come from a non-luminous source. For luminous objects, we can further break them down into two categories. The first one is some source of natural light. Natural light meaning it's just the way it is, for example, the sun, stars in the night sky, etc. But we also have artificial sources of light. This would be human-made objects, for example, light bulbs, cell phones, laptops, anything that gives off light that's human-made would be an artificial source of light. And kindly ignore this last part over here, that shouldn't have been included. And we'll move on. Okay, what we're going to do now is we're going to look at various sources of light. We're going to explain how they produce light and provide some examples. Let's begin perhaps with one of the most common sources of light, incandescence. And a common example that you see in everyday life would be an incandescent light bulb. How an incandescent light bulb works is as follows. There's a wire filament inside made of a metal called tungsten. As electricity passes through that wire filament, it heats it up, and as a result, light is produced. In reality, this is actually a very inefficient process. You'll notice that if you have an incandescent light bulb in your house, it becomes very hot after a period of time. So a lot of the energy is actually produced in the form of heat, and not all of it goes into producing light. More modern energy efficient light bulbs correct this problem, and we'll talk about that later. The next source of light would be light from a process known as electric discharge. A common example in everyday life would be lightning. Lightning is just an electric current, except rather than passing through a wire, it passes through the air. To make it, you need a cloud. When the ground is hot, it heats the air above it. This causes warm air to rise. As the warm air rises, water vapor cools and condenses to form a cloud. As this process continues, the cloud gets bigger and bigger. The area where clouds form is actually below freezing, so the water vapor starts turning into ice. All of those small bits of ice bump into each other, and that builds up a lot of electrical charge. A giant spark in the form of lightning occurs, and this is very similar to getting shocked with static electricity if you walk with socks over a carpet, let's say. Another example would be neon lights. The way this process generally works is as follows. When an electric current passes through a gas, the electricity causes the gas to glow. This produces light. Next up, we have phosphorescence. An example would be anything that glows in the dark. So if you have a toy or a sticker that glows in the dark, it's producing its own light, and this is through the process known as phosphorescence. How this works is as follows. The object absorbs UV light. Recall, that's ultraviolet light. And as it's doing this, it's absorbing energy. Eventually, it gives off some of this energy in the form of visible light. This process usually occurs slowly, which is why glow-in-the-dark objects can glow in the dark for a while. Next up, we have the process of fluorescence. Fluorescence is very similar to phosphorescence, except this process occurs immediately, whereas phosphorescence occurs more slowly over time. Examples in everyday life would be the ink found in highlighters, as well as fluorescent light bulbs. Okay, so just to summarize, this occurs when an object absorbs UV light and immediately releases the energy as visible light. So just to summarize again, fluorescence is very similar to phosphorescence. It just occurs much more rapidly, whereas phosphorescence occurs slowly over time. Next up, we have the process of chemiluminescence. This process occurs in those sticks that glow in the dark. Usually you'll see these being advertised at theme parks over the summer, and the way this works is due to a chemical reaction. The sticks usually contain two chemicals that are separated. When you then break it, you mix the chemicals together, and that process produces light. Recall from the chemistry unit, one way to tell that a chemical reaction has occurred is the production of light, which is exactly what's happening here. Next up, we have the process of bioluminescence. This process occurs in living organisms. For example, fireflies, jellyfish, and even some types of bacteria. In this sense, certain types of living organisms are literally glow in the dark. Next up, we have the process of triboluminescence. This process occurs when certain types of crystals are scratched, crushed, or rubbed together. If you've ever bit on a wintergreen candy in the dark, you may see this happening. You might also see it happening if you take 2 sugar cubes and rub them together. Try it. You'll have to be in a dark place though to notice the production of light if you get any at all. Next up we have LEDs. This is actually an acronym that stands for Light Emitting Diode. LEDs are much more efficient than incandescent light bulbs. They do not require a filament and they're much cooler to the touch, so less energy is wasted in the form of heat. In this case, light is produced when an electric current flows through a semiconductor. One example of this would be the element silicon. Of course, an example would be LED lights. And lastly, we have lasers. I'm sure we're all familiar with lasers, for example, laser pointers. As I'm sure you know, never point them in your eye, and you're actually going to learn why when you complete the homework later on. Something interesting that you may not have known though is that laser is actually an acronym. It stands for Light Amplification by Stimulated Emission of Radiation. The way how lasers work is quite complicated and goes way beyond the scope of this course, but just to break it down, lasers produce electromagnetic radiation of the same energy level. And this is important because you can get a laser producing one color of light. For example, red laser pointers, green laser pointers, blue laser pointers, etc. So something I'll mention here is that the wavelength of a wave, which is something we learned in lesson 1, tells you what the color of the visible light is. For example, blue light is around 400 nanometers, whereas red light is closer to 700 nanometers. So you can produce light of one wavelength, one color, or even one type of energy level. And usually the light is very intense, meaning it has a lot of energy. So the example I wrote down were laser pointers, but in terms of an application, lasers are used in manufacturing to burn hole through metal sheets. Another application would be laser eye surgery. So in that case, a doctor is literally using a laser to cut around your eye to perform whatever is needed in the operation. And that's going to wrap up lesson 2. Please complete the following questions on your own as homework. You may have to use the internet to research some of them. And of course, if you have any questions, don't hesitate to reach out. Thanks everyone, we'll see you in the next one.